Good afternoon, and welcome to the Society of Wetland Scientists June webinar, where we will be learning about wetland restoration in the Big Meadow Bog complex of Briar Island, Nova Scotia. Today's webinar is free to the public, and we're pleased to those of you new to this series have made its time to enjoy this wonderful program. My name is Louis Mantini. I'm a member of the SWS Webinar Committee, and I'm going to be your moderator today. Before we get started, I'd like to go over just a few housekeeping items. The general format for today's webinar will be 45 minutes of a presentation by our speaker, followed by approximately 15 minutes for questions and answers. At any time during the presentation, you can type your questions into the questions pane of your control panel shown in the slide, and I will pose the questions to our presenter at the end of the presentation. This webinar is being recorded, and you will receive a link to the recording following the webinar. We also ask that you take a moment to complete an evaluation survey that will help us plan future events. If you'd like a copy of today's slides, please find a PDF in the handout section of the control panel. And finally, if you are familiar with the SWS Twitter Symposium, you can tweet about today's webinar at hashtag SWS webinar. We're also proud to announce that this webinar has been pre-approved by the SWS Professional Certification Program and is applicable for continuing educational credits that you can apply to your professional wetland scientist certification or renewal. Participation certificates are available through an automated process initiated by an email from Michelle Sozek, our SWS business manager. This should occur in approximately 24 hours following the webinar. Please be certain to check your spam folder if you don't see it. Participation certificates are also available for those who watch webinar recordings, which can be found on our past webinars page, the website. So, with the logistics out of the way, let's get started with our webinar. Today, our speaker is Andy Sharp. Andy is a biologist with a master's degree in environmental design from the University of Calgary, Canada. Andy has been a projects manager at East Coast Aquatics Incorporated of Bridgetown, Nova Scotia since 2011. He's currently involved in the development and implementation of the restoration of wetland hydrology in the Big Meadow Bog, which, by the way, is the site of the globally endangered Eastern Mountain Avens. With that introduction, I'd like to turn control over to you, Andy.
Okay. There we go. Hi. Good afternoon, everyone. Thank you for joining us today. I'm going to be talking to you over the next few minutes about a wetland restoration project I've been involved in for the past 5 or 6 years, taking you through some of the things we've learned, some of the things we've gained, and bring you up to where the project is today. So for general orientation, I'm in Nova Scotia, Canada, on Canada's Atlantic coast. The project that we're going to be talking about today is on Briar Island, way down in the southwest corner of Nova Scotia, at the very end of Digby Neck, which is a long finger extending down from the mainland out into the Bay of Fundy and the Gulf of Maine. The waters around this are cold year-round with a damp coastal climate and extended freezing temperatures throughout the winter months. For, again, orientation's sake, what you're looking at is Digby Neck stretching up into the distance. Briar Island is the island closest to us, and then there's in the middle of the shot is Long Island, and then the mainland is in the distance. So accessing this island requires driving quite a distance. So, for example, it's 4 or 5 hours from the capital city, Halifax, and then you've got to get across 2 ferries to get to Briar Island. The circle is showing Big Meadow Bog. It's a large 60-hectare, 150-acre bog complex running roughly north-south through the island. The photo at the lower right, that's sort of the star of the show for today. That's the Eastern Mountain Avens. And that's really what catalyzed a lot of this project to really happen. Eastern Mountain Avens is a perennial member of the rose family. It's extremely restricted range, very limited populations that have suffered steep declines, leading to it to be listed as globally endangered. Digby Neck on Briar Island is the only known occurrence in Canada of this species, and there's one other subpopulation in the high mountains, White Mountains of New Hampshire, interesting enough. So two populations globally that we're going to be talking about, the only population in Canada for this presentation. So this was a fairly large group and a large project that brought together many partners. I think I've got most of the collaborators and partners listed here. This started with the statutory recovery team for this endangered species. We had involved both local and national conservation NGOs, 3 levels of government, 5 universities and colleges. The Big Meadow Bog project has also been, and its restoration has been, quite an active site for both undergraduate and graduate level research projects over the past 6-7 years, and they're still ongoing now and into the future on a really wide array of topics, from genetic diversity of the Eastern Mountain Avens to greenhouse gas emissions to mercury contamination. And so, as well as the actual restoration that I'm going to be talking to you today about, it's been a vehicle for a considerable amount of knowledge, scientific knowledge generation, as well as an opportunity for students at various levels to get out, get dirty, and learn about some really important field skills. So Briar Island, this is the only community on the island, Westport. It's a fishing community, not surprising, principally reliant on the lobster industry at present for its economic viability. And again, quite remote, only accessible via 2 ferries to get here, historically quite isolated as well. I debated whether to add this slide, and it came in at the last minute because I wanted to share with you quite a personal connection that I have with Briar Island. So these are my grandparents, and my grandfather was the minister at the Baptist Church on Briar Island, and you'll see it'll come up repeatedly in some images. And so I have very strong memories of going to the island as a child with my family, seeing grandparents and cousins, digging clams and doing lots of fun stuff. It was always a bit of a magical place. Fast forward 40 odd years, I've had the opportunity to go back as an adult in a very different context, but it's been a very rewarding professionally and personally to be able to be part of this project because of that long-standing connection I've had with the island. So today, I'm going to take you through a little bit on the alteration that was done, and then the design process and several phases of the restoration work that we carried out, bringing us up to today and where the challenges we're facing with adaptive management. This is going to be a roughly chronological order through the process that we've followed with this project. So, 1958, a fairly enterprising individual constructed a homemade caterpillar digger arrangement and set about digging some ditches in Big Meadow Bog. And he worked quite hard in digging about 3,700 meters of ditches, running the entire north-south length of the bog. They were about 2 meters wide, 2 meters deep, and were quite effective at starting the process of draining this large bog complex. Unfortunately, after only 1 year of attempts at cultivation on only a small part of the bog, the whole venture was given up, abandoned, and the site was left virtually untouched for the next 60 years, except that it drained and other changes occurred that I'll talk more about. And so we know a lot of this information from oral history. We spent quite a bit of time through this project tracking down the son of this individual in this photograph and interviewing them and documenting that both through individuals and photographs. And so this was a big part of our project initially was to better understand what happened, what were the alterations in the past, leading us to then come up with a plan as to what to do about it. So the arrow is pointing at the Baptist church that you saw a few moments ago. And it's for working on this large site, frequently the fog will roll in, we'll lose visibility, it's very brushy and shrubby. The Baptist church spire is visible from across the site. And so you'll see it coming up repeatedly as a reference point. The ditch, this was the central ditch in the bottom photo, quite deep, quite wide. But over the last 60 years, these ditches have deepened as the flowing water has cut into the soft peat surface. They've narrowed, most likely through slumping, and trees and shrubs have encroached. So these two photos are taken at about the same location. The top photo, basically you can't see the ditch. And there's been a large number of researchers that as they're wading through chest-high shrubs, will have fallen into the ditches because they were very well camouflaged by the dense shrub growth that had come in over the years. So down to the central ditch, the southern end of the island, again, certainly narrowed up and deepened, again, with the water cutting into that peat surface. I'm about 6 feet tall, sorry, and this is me standing in one of the ditches, again at the southwest corner. You can just see some rocks in the bottom of this ditch where the bedrock comes up to meet me here. And so my head is just at about grade, just about ground level. So the ditches were very persistent. They were still carrying water when we arrived at this site 4 or 5 years ago to begin to figure out what to do with this restoration. This is looking along one of the ditches entirely shaded by dense tree canopy. The trees colonized the site as it drained, and one of the first places they colonized were the spoil piles because they were slightly higher. And now when we arrived to begin this work, we were faced with trees upwards of 1 foot in diameter that we had to work around to begin the restoration process. One of the other aspects through the oral history interviews that we conducted were the uses that the members of the community made of Big Meadow Bog. We had good records for berry collection on the bog for jams and preserves. We had good evidence of duck hunting on a series of pools and ponds that occurred within this domed bog structure. With the construction of the ditches, you can see in the middle panel, all of these ponds and pools were drained quite effectively. Down in the bottom image, you can see the ditch structures, but all of those pools and ponds were drained. And so those community structures, those values that the community were making use of in the bog disappeared essentially. And so that was in our minds as we sought to come up with a restoration design for this project. So the company I work for, East Coast Aquatics, we were retained in 2015 by the recovery team for Eastern Mountain Avens to come up with a plan to restore the historic hydrology to the bog. We had peat depths across the bog between 2 and 6 meters deep. We had a range of landowners involved. Some of them were very committed and some were entirely non-engaged in the process. There were no roads into the site. And so that made access with equipment very tricky. As I mentioned, the peat, the ground surface was very soft and unstable, making it the only equipment that we could operate on the site was low ground pressure equipment such as small compact excavators. So we had the challenge of bringing materials in with the no road access, the landowner issue. Also at that time, there was fairly limited bog restoration experience in the province of Nova Scotia. On top of all this, we had to consider this critically endangered species and how we're going to ensure that we're addressing its habitat requirements. And finally, the herring gulls. You may be wondering why herring gulls are thrown in this list. They played quite a significant part in this story. So and this is a bit of a sequence I'll take you through. The herring gulls, as the bog drained and dried over the last 60 years, what was a very wet sphagnum surface substrate dried out into dry peat moss essentially. And herring gulls, this being a coastal island, always nested in the area, but they found this to be a very attractive location for nesting. They're a ground nesting bird. And so the herring gulls essentially flocked to the bog through the summer months to nest and raise their young. With the gulls nesting on the bog surface, this led through both defecation and mortalities to increases in nutrient levels within the bog, and a change from what was a fairly nutrient poor setting to a eutrophic setting with enrichments in nitrogen, nitrates, phosphates, as well as some other contaminants such as methyl mercury. The shift in the herring gull populations to the bog was also stimulated by some off-island food supplies that were buoying up the herring gull population. With the fertilization of the bog, coupled with its drying, we had tree encroachment and shrub encroachment, as well as a transition of the vegetation community from a heath-like sphagnum moss-dominated community to one dominated by weedy, invasive or exotic species. A lot of grasses, sort of commercial grasses, a lot of brambles encroached into this bog setting. And so we had a change both in the nutrient structure of the bog and the vegetation community. So one of the graduate students involved in this project, Kate Schlepper, applied some GPS tags to a couple of the nesting gulls in the bog, and it looked essentially like these gulls were going back and forth to the office every day because they had a very, very consistent travel pattern. And when we dug a little bit deeper, where they were flying every day were to a couple of fish processing plants on the coast, and there were some off-island mink farms where mink were raised for their fur. These farms happen to have fairly poor waste management practices at that time. So these off-island food supplies, anthropogenic in nature, were buoying up, stimulating the herring gull population on the island. 2016, there were in the region of 3,000 active nests on the island, and the herring gulls, they moved through the bog. They started at the left of this image approximately 30 years ago, and we know this from historic air photos, and they've essentially moved to the north. They seem to like the fresh sphagnum surface, not the fertilized weedy surface that comes up after they've been there for a few years. And so contending with the herring gulls was a significant factor in developing our restoration plan. So when we set about the job of coming up with a restoration plan, we really tried to bring together several disparate pieces to do this. Starting in the lower left, we conducted a large number of foot field surveys across the island. The heavy tree and shrub cover made aerial photography essentially not very useful because so much of the ground surface was obscured. And so we felt we had to put the time on the ground to understand the fine scale detail. This on-the-ground work, coupled with oral history and where we could access the historic air photos, allowed us to decipher the layers of past impacts and alterations of the site. We conducted extensive literature reviews and then looked abroad, specifically to the United Kingdom, to draw on some of their best practice for developing some preliminary treatments for the bog. And we trialed these treatments at a small scale, looking at if we block the ditches, as the photo in the top left, if we block the ditches, what would be the response of water levels? So we used some steel plates, we inserted them across the ditches, after which we installed a series of monitoring arrays around these locations, and then tracked the response of water levels to ditch blocks. So we developed some empirical data using our anticipated treatment, and we evaluated that empirical data to assess whether really it was going to work once it was scaled up for the larger site. I wanted to at this point acknowledge a couple of individuals that were crucial in these earlier stages. Andrew McBride on the left and Matt Cross on the right. So as I mentioned, while we were doing our literature reviews, it became apparent that there was an extensive track record of bog restoration in the United Kingdom, but the journals cited quite a number of different methods that had been used across the UK, and it left me unclear which ones actually worked. And so on a couple of different family holidays to the United Kingdom, I sought out these two bog restoration practitioners and arranged to go meet them. And so I met with Matt Cross and the Nidderdale Moor on North Yorkshire, and then separately Andrew in southern Scotland, not far from Edinburgh. And it was virtually like night and day to be able to go and walk some of these sites with individuals that have evaluated and tried a range of techniques over many, many years, again, to really benefit from their expertise. So I would really encourage, if any of you listening here are thinking about a bog restoration project, to look outside, especially Northern Europe, United Kingdom. There's a great deal of expertise available there. And again, going back, we saw in the literature a range of different ditch blocking techniques that were being described, ranging from corrugated steel, corrugated plastic, wooden timbers, sheet piles, placement of bales of heather, wood waste, bunds, peat dams, and it was unclear which of these really worked in practice. And by spending some time with these individuals, we were able to walk over some sites, and they were able to say very directly, we tried that, it doesn't work. We tried another technique over here, it didn't work. The third one, yeah, that's one that's proving to be most effective. And so that first-hand experience was very helpful for us in formulating our plans. So what did we do with this restoration in Big Meadow Bog? We installed 137 ditch blocks, essentially peat dams. I'll talk more about those in a moment. We reprofiled the stiff edges of all of those 3,700 meters of ditches. We cleared the trees back to the 1955 boundaries, and we redirected some surface flows that had been altered by a runway construction. I'll come into that near the end. So ditch blocks. Before I come to that, yes. So the blue lines are the ditches that were constructed in Big Meadow Bog in 1955, draining north and south. And so we set out to construct ditch blocks at 137 locations, shown here by the yellow dots. The spacing of our ditch blocks was dependent on the steepness of the ground surface. So where the ground surface was steeper at the north and south ends of the bog, we put our ditch blocks closer together. Where it was flat, where the bog was flatter near the center, we stretched them out to a maximum of 50 meters apart. In some respects, we may well have overbuilt this. We may well have put in more ditch blocks than we needed. And this was perhaps us being fairly conservative in that we didn't really want to have to go back and try and fix blown out ditch blocks later after we'd left the site. So we certainly felt we needed to err on the side of caution when in this number of placements that we put in. Ditch blocks, this technique was borrowed directly from the United Kingdom. It involves digging, here we've got a trend, the ditch running left to right across the screen, and installing the ditch blocks involved digging a key into the banks and bottom of the ditch and excavating dark catatelmic peat from a borrow pit immediately adjacent. And the peat is then used to build a dam up to and above grade, and then all of that is topped with vegetated sods. The borrow pit edges are smooth, and that provides a location for water flow to be redirected over a broad overland area into dense vegetation. Most cases, we're able to do this without moving our excavator, because every movement of the excavator meant a risk of breaking through and getting stuck. And so this technique was adapted to try and to the setting we were working in. Side view of the ditch blocks, again, they're keyed into the bottom and sides of the ditch. They come up above the ground surface. The success of these working depends significantly on the quality of the excavator operator. And if you're going to go down this road, once you've got someone who's good at their job and knows how to do these reliably, you should keep them, because they're the crucial part in all of this. The peat is built up in lifts, maybe 1 foot high lifts, and pressure and packed into place to make a waterproof dam. It's important that the peat dams are not too high. They need to be built above the grade to allow for settlement over time. Ideally, following settlement, you don't want them any more than perhaps 20 centimeters above grade. Otherwise, they'll dry out, you'll get erosion, and an opportunity for invasive species to come in. I think that's everything. The second component of the restoration plan was reprofiling. As I mentioned earlier, the ditches were steep-sided, sometimes almost vertical sides. And what we set out to do was to reprofile or smooth out those steep edges. This involved peeling back the vegetation sod at the top, breaking down the sides of the ditch with an excavator, and then laying the sod back into that depression. Again, all this was done with an excavator. Once the ditches had been reprofiled, they were also a good location to place wood waste, cut trees and shrubs, providing a range of water depths and a good habitat for sphagnum reestablishment. Again, I came to believe throughout the process that the ditch profiling was just as important as the ditch blocks in impeding water flow. By adding vegetation debris and cuttings, and by smoothing the ditch surfaces, we added roughness, which significantly decreased water velocity. So I've got now a series of photos for you showing how these restoration projects sort of unfolded. We started in the Southwest in a very small pilot phase. We couldn't get access to all of the bog at that stage because of land ownership issues, and so we were confined to one corner. But this gave us an opportunity to try some of these techniques on a small scale. As I showed you some photos earlier of me standing in a ditch under a tree canopy, and this is where that photo was taken. So we had to cut all of the trees off those 1955 spoil piles to allow our equipment to come in. And the box is showing the ditch that is carrying water flow at the time of this photo. There were significant flows when we arrived to do our work just after spring melt in April. We started constructing our ditch blocks at the head of the ditch. And so once the first ditch block had gone in, the constructed ditch immediately dried out. And so it was an easier work site from then on because it was dry. One of the interesting and surprisingly immediate side effects of this was that as soon as we started putting in our ditch blocks in this 1955 ditch, an adjacent water channel, a natural water channel, which had been dry for the last 60 odd years, immediately started carrying the flows again. So a channel that had been on that landscape dry for that long was reactivated within half a day of us starting this project. So one of the challenges at this particular location in the bog was, I mentioned the tree canopy, and so we had underneath the dense spruce canopy, there was very little in the way of vegetation mats for us to use. So we ended up with a fairly muddy site, unfortunately, as we worked through it. Later on as we go through some of these other photos, the vegetation mats were very useful in spreading over the freshly exposed peat to stabilize it. We didn't have the advantage of that at this location. Small compact excavator working the ditch that he's working on filling is on the left, just to the left of the bucket. On the right, the water that you can see is the reactivated natural channel. And again, you can see it was very woody, a lot of wood debris that we had to cut off and contend with roots and stumps, etc., for this one corner of the bog. So midway through construction, we had water pooling up to the surface behind all of our constructed ditch blocks. Several months post-construction, things had greened up considerably, stabilized, and were looking pretty good. Again, the water on the left is the natural water course pre-1955. By the end of that summer, again, things were looking quite positive. The actual constructed ditch was becoming largely obscured. And again, 13 months later, we had a fairly diverse herbaceous native species encroachment. We didn't do any seeding or any planting at this location. This is entirely natural regeneration. And I think using whatever vegetation we could grab and place in these locations at the time of construction provided both seed reservoir but also live cuttings that made this quite viable. 2017, we started on the central and the largest component of the ditch. The red circle is just in the very center of the red circle. You can see the church spire off in the distance to the north. And so you can see the degree of shrub and cane encroachment into this as he's just digging out the keys for a ditch block here. And again, one of the steeper sided ditches building up a ditch block. So nearing the end of the central ditch construction phase, so here, I think, yes, my mouse works. Ditch block right here, another one in the distance, and everything is being reprofiled. So this would have been perhaps a meter, meter and a half deep prior to the restoration. The left side, where I'm just tracing right now, was the spoil pile. And one of the things we found is that the excavators along the spoil pile provided the best travel for the excavator. It was the driest location and the most stable to work off of. And that was a bit of a learning curve for us. So 6 weeks post-construction, things were looking quite good. We had water ponding up to the surface along the central ditch, good retention by our ditch blocks, everything was stable. And again, later that summer, this is the central ditch again. So one of the very encouraging features for me was the lily ponds beginning to charge with water several months into the construction phase. So Big Lily Pond immediately started filling with water after 60 years of being dry, dry depression, which was very, again, surprising, but very encouraging. So there's a long shot following completion of the central ditch construction. Church spires in the north, in the top right corner, and we can see that the water is up to or very near the ground surface. Just to the left of the church spire at the top, you can see the runway, and I'm going to come back to that in a few minutes as another thing we had to address in this photo. I'll just point out to it here as well. You can see the extent of both tree and shrub encroachment across the site. Some areas here on the western side and up in the northeastern side, quite extensive tree growth, and that was also part of our restoration prescriptions, and I'll come to those in just a few minutes. So here's an aerial view to give you a better idea of what this pattern of ditch blocks looked like. So here we can see 4 ditch blocks covered with vegetation, and this was taken about 3 or 4 months post-construction. You can see the adjacent borrow pits where the surface vegetation was removed, providing access to the catatelmic peat. This is peat that had never dried out, that had always, from depth, typically down at least 2 feet below the surface, and that was the peat that we used for building the ditch blocks. Again, this from the experience in the UK, it has greater structural integrity and holds up better, makes a better dam. And the edges of those ditch blocks were smoothed down to allow water to spill out into the adjacent dense vegetation. You can see in one of these, right where I'm putting there's some water bleeding around the end. We had that on a number of occasions, and we've watched them, and they haven't really got any worse. We were wondering when we first spotted some of these locations with the water end cutting around our ditch blocks, whether it was going to unravel. But I think that goes back to our fairly conservative design and putting in perhaps many more ditch blocks than were minimally required. And so the water elevation fall across any one of these is not significant, in the range of 20 centimeters. And so to date, all of these have remained stable. Tree clearing, again, we used 1955 air photos to determine some boundaries of what the bog looked like. And this was all handwork, both brush saw and chainsaw crews on the bog. There was fairly good evidence that we were basing this on the United Kingdom, that if trees and shrubs, because of their evapotranspiration potential, will delay the hydrology restoration. And so cutting them was necessary. The recovery team had extensive discussions about whether the wood debris should be removed from the site or not. In the end, we decided it was simply too disruptive. And so the trees were cut and limbed so that the trunks fell onto the ground to promote decomposition quickly, and the shrubs were just dropped in place. The runway. So a runway was constructed on the island by a landowner around 2010. We know from catchment mapping using digital elevation models that prior to the runway being constructed, there were a number of subcatchments that fed Big Meadow Bog, the northwest corner, an area known as the BM1 lag. The BM1 lag was a bit of a stronghold for the Eastern Mountain Avens. It was a priority area for us to pay attention to. And when we looked at this in more detail, we realized that once the runway went in, it changed the surface water flows. Water was either diverted around the south end of the runway or through a single central culvert into a pond and then down to the northern end of the bog, essentially creating a bit of a water shadow for the BM1 lag. And we knew from monitoring well data that water levels in the BM1 lag were upwards of a meter below the ground surface. So it was a very dry location which fit with the alterations caused by the runway. And so we felt that the blocking of the ditches and the reprofiling of the ditches was helpful for the BM1 lag, but we needed to do more work to try and address these hydrology issues. What we did, again, we had to have extensive consultations with the landowner. He wanted to maintain his runway. He wanted to maintain the ponds. He didn't want any changes to the culverts under the runway. So we constructed a number of offshoot ditches, meandering channels, shown here in orange, to take the surface flows from the perimeter of the runway and send them off into some treed swamps that were upslope of the BM1 lag. And secondly, the green is a channel that we constructed to take flows from the pond via a culvert and again direct those to the BM1 lag. So we maintained the landowner's culvert under the runway. The pond maintained its outflow, but it's essentially the base flow that had been going through the pond was now directed towards BM1. So the orange channel, oh yes, this is the pond. We used basically an agriculture style drop inlet and put that in the pond to take the base flow, and that was directed through a constructed channel about 180 meters long. Terminating the photo on the left is where this flow ends upslope of the BM1 lag. We constructed a wide, shallow, rock-lined overflow trench. And the intention here being that flow coming into this location from the pond would both infiltrate into the shallow groundwater, providing base flow, and provide some surface flow going down into the BM1 lag. And the two photos here are the southern end of the runway where we constructed meandering channels into a treed swamp, again, to take that base flow, base surface flow, and redirect it to allow gradual infiltration. So I mentioned at the beginning my family connection with Briar Island. And so it was particularly important to me that there be something left for Briar Island and the residents there once all of the wetland scientists go away, once this construction, once the restoration was complete. And so I was very pleased that near the end of our restoration, we were able to be a partner in the construction of a boardwalk, which will provide members of the public access into the bog as a tourist amenity. Briar Island already has a thriving ecotourism industry centered around whale watching and bird watching. And so a globally endangered plant, which is thriving through restoration efforts, fits naturally with that. And particularly, it was important because the residents of Briar Island, they're going to be the stewards of this species and this site once we all go back to our other, onto the next restoration project. So the community spearheaded the construction of a boardwalk. It, as a fundraiser, had its very first inaugural fun run in the island last September, and I think many more are going to be planned. And so I think that's an important component of this larger restoration project, is how it fits with the community. So that brings us up to today. So we are continuing to monitor the herring gull populations, the Eastern Mountain Avens, both its abundance and distribution, the wetland hydrology. The good news is that water levels within the bog are at or very near our target. We may be seeing some decline in the herring gull populations. We knew from some of the earlier work that they have a fairly high degree of nest fidelity, and so it might take several years of wet ground substrate, wetted ground, and nest failures before they decide to relocate. And unfortunately, we're still seeing declines in the numbers of Eastern Mountain Avens. And so Recovery Group and project partners are actually meeting this month to look at what are the next steps we need to be taking, given the other pieces appear to be going in the right direction. I'd like to close this with a few takeaway thoughts for you when you're approaching your next wetland restoration project. I mentioned this a moment ago, but think about the community. Again, they are going to be the stewards of these sites as we finish these projects and move on to our next challenge. But we have to somehow provide members of the community with a vested interest in carrying on the work and protecting these attributes that we've worked so hard to create. I'm a strong believer in field work. I think it's simply irreplaceable. Remote sensing technologies are wonderful, but they just can't replace the on-the-ground understanding. In my case, I talked to you earlier about the lily ponds, and for me, it was a light bulb moment. Early on in our field work, I was wading through chest-deep shrubs, mapping, and I fell into a dry pond. And it took me a while to work out what did I fall into, because these things weren't mapped at that point. They weren't visible from air photos, but it was a dry pond. And so that was the light bulb moment for me to understand that historic features, water features, were still on the ground. The depression was still there. We just had to add the water. Best practice, it's out there. We don't need to reinvent the wheel with our restoration projects. I strongly encourage you to look outside your community, your region, your state, or your country to seek out some best practice. And finally, think about a restoration trajectory, setting things in the right direction. Realistically, this is going to be a very long trajectory for this site, but I think we've got it moving in the right direction. Thank you very much. Are you there, Lewis?
Okay, excuse me. I was talking to myself because I was muted. This is Lewis, and thank you very much, Andy. That was extremely interesting, and we will get to our questions. I did want to say that I found the daily activities of the herring gulls to be very endearing. Makes me want to get my own gull and put like a tracking device on to see if he goes to the landfill every day.
GPS tags are magical little devices for understanding where creatures are going.
So one of the first question that I have is you kind of answered it, but I wanted to build on it a little bit because the question is, did you have any issues with the peat blocks washing away? The individual asking the question thought that this highly organic soil would be susceptible to erosion. And you had mentioned, forgive me because I love your accent, but I didn't quite understand what type of peat. It almost sounded like you said catatonic, but I don't think that's it.
Uh,
Um,
yes, catatelmic. And so two broad horizons of peat. The peat that's up near the surface that gets exposed to air and oxygen and it's more friable. Peat at depth, catatelmic peat is always wetted. There's with no oxygen available, and it has greater structural integrity. And so, no, we didn't have any problems with the peat washing away. A couple of factors in that. Uh, we constructed our ditch blocks from the head of the ditch down, so there was never any flow. Once our first ditch blocks went in, the ditches were dry. We use the catatelmic peat, which is stronger. We placed it gently, trying to keep it in intact blocks and gently tamped it into place. We built it up in lifts and then the tops of the ditch blocks were covered in vegetation mats from that location that were gently draped over them. And that allowed for immediate vegetation growth and stabilization of the surface. So of 137, we've walked the site repeatedly and none of them, and again, we don't really have water velocity. We have so many ditch blocks in place that there is no water velocity between one ditch block to the next.
okay, well that makes perfect sense. Um, I was kind of holding a thought or question from the beginning regarding uh, the methyl mercury
Yes,
being a problem. I'm in Florida, right? And
yeah,
I guess I'm more familiar with problems with methyl mercury in aquatic environments, and usually the more I guess the higher in the higher pH environment. Say if you have a, a lake that
yeah,
has an algae bloom on it, you'll have more of a chance of or less of a chance of methyl mercury being a problem than you would in a dark water stream.
yes.
I was curious, was there any was this was I guess methyl mercury being a problem due to transformation of the chemistry of the environment, or is it imported?
You're right. It's the latter. The seagulls are probably thought to be a biovector, essentially bringing in mercury to the location in very small amounts and allowing, though, its introduction into the site and then magnification. And because of wetting, drying going on as the bog is re-wetting through the restoration, whether the question is still being investigated, creating the conditions for the methylation of the mercury that's being brought in by the herring gulls.
Okay. Well, maybe those goals aren't that endearing after all.
No, after being dive bombed repeatedly, I have no love for them.
Uh, let me see. I was curious also in there we have a question that reads as with the completion of the physical restoration work, what is your anticipated time frame for the biological response? And I was kind of specifically thinking about the ponds, the lily ponds.
Yep.
Um, if I were, to guess, just looking at some of the shrubs and things, it looks like it's probably, I guess what we would call a common name, a loosestrife or something like that. And,
Yes.
and were you just, did you have any, I guess, did you help it along in any way with herbicides or anything like that, or are you strictly, going with hydrologic restoration and driving the?
We certainly, I'm aware of some restorations that do use herbicide. The and this was brought up to the steering committee, and they decided they didn't want to go down that road. So this was all strictly changing the hydrology conditions and letting the plant community respond accordingly. As far as time frame for the restoration, we've seen, I think, pretty much a full restoration of hydrology within 1 to 3 years. time frame for nutrient regime to go from eutrophic to oligotrophic, 5, 10, 15, and maybe in that same time frame, gull populations will reduce as they shift to other nesting locations. And time frame for transition of the vegetation community for the woody, weedy species that are there presently to be shouldered out by bog-specific aquatic species that are characteristic of a low nutrient environment bog. Decades, 30 years, 50 years. It's going to be a long time before that transition occurs, I think.
Okay, all right. Here's another. If the entire channel was reprofiled, what prevented the project managers from filling in the entire length? Would you recommend filling in the channel if it is possible?
Yes, I think filling it in, as long as the filling it in doesn't create another scar, and I think it's important that you can't rely on filling it in to make a watertight seal. It certainly contributes to stopping water flow. You still need to put in the ditch blocks because they're the component in this larger design that is impeding the flow. The reprofiling contributes to that, but it is not enough on its own, I think.
Okay. And monitoring.
Yes.
How are you monitoring water levels? Automatic data loggers in,
Yes.
okay.
A series of data loggers deployed in wells throughout the bog and at adjacent reference sites.
Okay.
And so we had a fairly good data set prior to restoration, through the restoration, and now going forward as the project sort of readjusts to these new conditions.
Interesting. And more hydrology. What level of base flow did the ditch have before blocking? How did you decide on the frequency of the blocks? Oh, well, I think you've answered
Sure.
them. Okay.
The placement of the ditch blocks, we used the slope of the adjacent ground surface as our guide. So from a digital elevation model, we knew that the bog was fairly flat in its center. It was a raised dome bog, and then it sloped down at its edges. And so we wanted no more than a 20 centimeter. So that's that. I'm doing conversions to inches. I apologize. That's going to be 8 to 10 inches. No more than 20 centimeter drop in the ground surface between each of our ditch blocks, because we were envisioning that's going to be our water surface. No more than a 20 centimeter water surface drop across an individual ditch block, and the ditch blocks were never any more than 50 meters apart in terms of linear spacing. So we took a digital elevation model and just started the greater the slope of the bog, the closer the ditch blocks were together.
Gotcha. And was there any preliminary flow measurement conducted in, I guess, in the ditch prior?
Yes, we did have discharge monitoring on all of the ditches prior, so we knew sort of what volume we were dealing with. But again, the strategy of the ditch blocks was to complete 100% impede the flow and redirect it back into the dense existing vegetation of the bog and reactivate the historic watercourses that were still there in the landscape, just buried under the shrubs.
All right.
And also recognizing we can't predict this in its entirety, that there's going to be a certain amount of reorientating of the whole hydrology structure, and that's going to be part of just letting the system go on its trajectory.
All right. Last questions.
Sure.
Last question. Were there any, I guess, regulatory or permitting requirements when you worked with the stormwater management system of the runway?
Yes. Sorry, let me take that back. There were no regulatory issues. It was entirely on private property, and we don't really have that system in place uh, here. And fortunately, we're able to wrap the runway work within the larger permit to do the restoration of the bog, and so we didn't have to get any specific regulatory issues addressed with the runway component.
Okay. Andy, this has been great. I've
Okay,
really enjoyed this, man. And
good.
with that, I'm going to make a couple last announcements. The next webinar, of course, is planned for July 18th, when Dave Walker and Brian Smith will present how to construct better constructed wetlands. And we also, let's see, would like to conclude by thanking everyone for taking the time today to join us for today's webinar.
Okay,
And with that,
thank you very much.
thank you.